This is question number 7, paper 42, October-November 2024, CIE 9701. The question is that benzene reacts with chlorine gas to form chlorobenzene. This reaction can be described as the reaction between benzene molecule and chloronium ion. The chloronium ion are formed by adding a suitable catalyst to the chlorine gas. Give the name or formula. It means you can write the name as well as the formula of a catalyst that can be used for this reaction. So the catalyst usually used in this reaction is aluminum chloride. So you have both the option whether you write down the name aluminum chloride or you can use the formula of aluminum chloride. Aluminum belongs to group 3, so it has 3+ charge, and chloride has -1 charge. So the formula would be this, as you have seen from your O level, that the charge number is written as a subscript of the alternate ions. Okay, this is the mechanism shown here, and chloronium ion act as electrophile. So electron cloud or the pi electron ring system or the delocalized electron system attacks on the electrophile, and as a result the sigma complex is formed, and finally the product is obtained when deprotonation occur here. So what is the question? The moment of pair of electron is represented by X. This is the one moment in the diagram, and second moment is the Y. Question is state the question is that state whether the pair of electron is before step 1. So step 1 is there. So before step 1, this electron pair is the ring system of the benzene. That is the delocalized ring. And you can also answer that these are the pi electrons in the ring. Instead, whether where this pair of the electron is after step 1. So after step 1, where is this pair of electron? So actually, this bond was already present, but not shown here. In benzene, we don't show hydrogen atoms or their bonds. So actually, now this is the bond between this carbon and chlorine. So carbon of the benzene and between chlorine in this bond, this is present. Okay. Now the next question is the moment of another pair of electrons is represented by Y in diagram 2. State where the pair of electron is before step 2. So you can see that this is the step 2, and before step 2, this pair of electron Y is in between carbon and hydrogen. So answer is carbon and hydrogen. The next part is state whether where this pair of electron is after step 2. So as electron is transferred into the benzene ring and the delocalized system is re-established here. So where is it? It is the delocalized ring. Delocalized electron cloud or the delocalized ring. Now the question number 2, no, the part C is asking about there are 6 carbon atoms in diagram 2. State how many of these carbon atoms are sp hybridized, sp2 hybridized, and sp3 hybridized. So come again to the diagram. In this diagram 2, it is easy to understand that this carbon is forming 4 bonds. So definitely this is the sp3 carbon while rest of the carbon atoms are sp2 because they are forming only 3 bonds, because at every corner there is a hydrogen, nothing else. So sp2 and no carbon is there. So out of 6, 1 carbon is sp3, 5 carbon atoms are sp2, and nil or none of them is sp hybridized. Okay, nil or 0. Okay, so that is the question C. And now come to the next part. This is the part D of the question number 7. Complete the equation of this reaction between benzene and chlorine. So we know that the reaction is with chlorine. So as a result, the catalyst that we use is aluminum chloride, but they didn't ask about this. Even if you write, then no problem, but better to avoid this. And the product would be C6H5Cl, that is chlorobenzene. And along with this, HCl is formed. So this is part D of this question. And now proceed to the next question. Now question E, the part E says that the mechanism of this reaction is electrophilic substitution reaction, that we know that we have already discussed. Complete the following sentence, write formulae in the gaps provided. During this reaction, the electrophile is chloroniamine. You cannot write here chlorine. You must write chloroniamine Cl plus, because Cl is not electrophile, Cl plus is electrophile, and a dash atom in benzene is substituted. So actually the atom that is being substituted is hydrogen. हाइड्रोजन की जगह पर आ रहा है, तो हाइड्रोजन is substituted in benzene ring by chlorine atom. So chlorine is actually displacing hydrogen. And now the part F. Part F has 2 components, and this is the last component of this question number 7. Chloroethane reacts with sodium hydroxide in aqueous. Remember that the reaction in aqueous and alcoholic condition is different, but chlorobenzene does not. Name the mechanism of this reaction that chloroethane undergoes with sodium hydroxide, and identify the major organic product that is formed. So remember that aqueous sodium hydroxide undergoes nucleophilic substitution reaction. So this is nucleophilic substitution. And the major product would be ethanol, because it will replace the chlorine. So after this substitution, the product would be, if it was chloroethane, so it becomes ethanol. And remember that if it were sodium hydroxide was in alcohol, then the mechanism would be elimination reaction, and the product would be ethene. So you should remember the difference of the reaction and the condition of the reagent. Okay. Explain the difference in reactivity of chloroethane and chlorobenzene when treated with sodium hydroxide in aqueous condition. So chlorobenzene does not react with aqueous sodium hydroxide in normal condition, in which chloroethane is reacting. Why? Actually, what happens when there is a chlorine atom on benzene ring? So what happens that actually these electron pairs, the lone pair in benzene, shifted here, and as a result is moved to here. So what would be the result? You can see in this diagram, these are the resonating structure. I'm not going in much detail, but it is important to let you know that there would be a double bond and it gets positive charge, and here it is negative. And similarly, this ring will delocalized, and in most of the time there would be the chlorine and carbon double bond. So actually this is the main reason, the delocalization of, because delocalization of lone pairs of chlorine, what does it do? With pi electron system, pi electron system in benzene. Pi electron system in benzene makes or create carbon chlorine bond much stronger. So as this bond has become much stronger, so it is why it is much stronger? Because, or better to write as it becomes partly double. Partly double, why I'm saying partly double? Because it does not remain double, but in most of the time it remains double. So it is partly doubled, partly double bond. So that's the reason that this substitution, this nucleophilic substitution is not possible in chlorobenzene in normal condition, where in alkane it can be substituted. So that's all for this question.